He likes pizza.
What are you doing?
I got this new app that tells me, like, you can put in someone else, and then you can put in what all the things they like and stuff, and it tells you how compatible you are with them. So it tells me how much I'm alike with my husband.
So, like, we were talking about compatible numbers, and then you thought you'd go on and find an app to see how compatible you and your husband are?
Well, you talked about compatible numbers being numbers that are alike that you can do mentally, and I thought compatible. See how compatible I am with my husband. See how much we are alike.
But you know that compatible numbers is not the same thing as compatible with your husband.
But it's kind of the same.
Well, compatible with your husband is like, oh, we have this in common, and no, we should get along, we should be married. Whereas compatible means, with the numbers, is like numbers that are easy to do in your head.
You just wait. By the end of this video, I'm going to find out how it fits together.
Okay.
All right, let's talk about compatible numbers. I have two numbers here. We're going to multiply together 92 and 12. And when we talk about compatible numbers, we also kind of talk about rounding, but they're different in this case. So when we round, we have a little rule that we use that says 5 or more, raise the score, which means if the number is 5, 6, 7, 8, or 9, we're going to raise the score. If it's 4 or less, 4, 3, 2, or 1, we're going to let it rest. Okay? So what that means is we have a bossy neighbor. We all have a bossy neighbor. We have that one student sitting on the right of us. Look at him. Point at him. Tell them how bossy they are. They're on my right now. And they're going to tell us what to do. So if I'm looking at, and I want you to pay attention on your notes here, 1, 2, and 3 are the same exact problem, but they're going to be solved differently. And they have different rules above them. So the first one, we're going to just round one factor. So I'm going to try and get numbers that are easy to do in my head. I'm going to leave, and we're just going to round one of them. I'm going to choose to round 12. I think 12 is a better number. Because if I can get 12 to a number that ends in a 0, I can easily multiply then by 92. So 12, here we go, bossy neighbor is the 2. 4 or less, which would include 2, is going to tell the 1 to rest, and everything behind it becomes a 0. And I think we could all agree that 12 is really close to 10. So now we can in our head do 92 times 10 very easily. If you caught Miss Rutledge's trick earlier, or in a lesson previously, she said to do 92 times 1 and then just add on however many zeros you had. That looked like this in the other video, or would have looked like this. 92 times 1 was 92. Count how many zeros you have, and you've got 1 0. So it's the same kind of thing. Just multiply and add on however many zeros you have. So 920. Now if you look at the second one, it says round both factors. So 92, if I use my rounding rule, 2 is my bossy neighbor. It's going to tell the 9 to rest. Rest at 9, add a 0 behind it. 90 is really close to 92. 12, my bossy neighbor. If I'm trying to get to the nearest tens place, my bossy neighbor is in my ones place. So 2 is going to tell the 1 to rest. And then again, I can use my power of 10 trick, and I can go 9 times 1 is 9, and I have 2 zeros. And if I want to write that horizontally, 9 times 1 is 9, and I've got 2 zeros.
Wait a second.
900.
But this one only had 1 0, and this one had 2. Why did you put 1 here and 2 here?
Because in my problem, I only had 1 0, and in my problem down here, I had 2.
Oh.
So make sure you count those zeros, okay? Now, the next one is using compatible numbers. So this was rounding. We rounded using 5 or more, 4 or less rule. Now we're going to look at numbers that are compatible together. When I think of compatible numbers, I think of numbers that are easy to work with mentally. So any number that really ends in a 0 is an easy number to work with.
Can I ask you a question?
Sure.
Is it easy to get along with your husband?
Well, most days.
So you guys are kind of compatible in that it's easy to get along? Like you kind of know his...
See, you're finding how it works.
Oh man, I'm helping you out.
So 92, a number that's really close to 92, that ends in a 0, would be, you could go 90, but you know what? Yeah, let's go 90. Let's see what happens when we go with 90. Did we already do 90 times 10? We already did 90 times 10, so let's go with 100, since we already did 90 times 10. And then 12, a number that's really compatible with 12 that ends in a 0 is a 10. And if I use my little trick, 1 times 1 is 1. Count my zeros. How many do I have, Miss Rutledge?
3.
3, so I get 3 in my answer this time. So if you take a look back at all of our answers, we had 920, 900, and 1,000. Now, we don't use compatible numbers and rounding numbers when we want an exact answer, but we use them when we want to get close to the answer. If we want to kind of check ourselves to see if we're somewhat right whenever we do the actual multiplication, this is what it would be good for, compatible and rounding numbers. Okay? All right, the next part on your notes sheet is a table, and I just want to kind of explain it to you. It has a pattern to it. If you look at it, I'm going to try to get it in front of them. Right there. Okay, if you look at this, notice that the first thing is the cost of one fish. So we're going to pretend here that we're going to pay $2 for a fish, goldfish. And in this power of 10 box is how many we're going to buy each time. So the first time we spent $2 and we bought one fish. Well, that's going to cost me $2. How many zeros do I have in this product of 2? None. No zeros. That's why I have 0 in this box. Now let's go back over here. I paid $2 for a goldfish. This time I bought 10 goldfish. So 2 times 10 is 20. How many zeros do I have in that product? 1. And it's right there, 2, 0, 1, 0. Okay, let's go back. This time I'm going to pay $2 still, but I'm going to buy 100 goldfish. So 2 times 100 is 200. How many zeros do I have in that product? 2. And the last one, I'm going to buy 1,000 goldfish. So 1,000 times 2 is 2,000. And how many zeros do I have in that product? 3. So I hope that you've seen the pattern here. You can look at your product, you can look at your power of 10, and you can see how many zeros are in that product, and that'll tell you if there's 1 0 in your power of 10, there's going to be 1 0 in your product. If there's 2 zeros in your power of 10, 2 zeros in your product.
Now, Mrs. Roy, I have a question. What's a power of 10?
Well, a power of 10 is any number, it sounds power of 10. So any number that ends or starts with the 10. So you've got 10, 100, 1,000, 10,000, 100,000. They're our place value chart, basically.
Oh, okay.
Okay?
Very cool. All right, I'm going to do number 5. So we've got 13, hope that shows up, times 10 to the second power, or we would say 10 squared. Now, we looked at exponents in the last lesson, and we talked about those, but now what if we have to actually multiply them out? I could go back and do my factor tree, but that would take a whole lot of time. I could just use what Mrs. Roy has been talking about and use my multiplication patterns. So, first off, I have to figure out what is 10 squared. Now remember, this isn't 20. This isn't 13 times 20. We don't multiply that. This would be like doing 10 times 10.
It's almost like stretching it back out.
It is, almost stretching it back out. So I've got 13 times 10 times 10. Well, if I look at that, I can do 13 times 1 times 1, which is just 13. And then I just have to add these 2 zeros.
And you can't count this one because she replaced that with 10 times 10. It was the same thing.
Yep.
So.
Now, here's what I like to do, though, because exponents are super easy. Let me show you the trick here. So I originally had 10 squared. So what I can actually do is I can say 13 times 10 squared is I literally take this number, since this is 10, I can take this number, 13, and I can add however many zeros. I don't count that 0 because that's telling me it's a power of 10. But I can say, well, there's 2, so I'm going to add 2 zeros. And look, I get the exact same thing either way I did it.
Or 13 times 1 is 13 plus those 2 zeros.
Yep. It gives me the exact same thing. So I like the ones with exponents. Some people think they're scarier, but I like them because I feel like it goes way faster.
Fast. Yeah.
They are fast. Okay. Number 6 on your notes page. I have to remember
40
the problem.
times 7,000.
40 is the big one. times 7,000.
And that would take you a very long time if you were to traditionally multiply
Oh
that
my
out.
word, there'd be so many zeros. It'd just be 0 times 0 times 0 times 0 times 0 times 0, and I'd probably get lost in all the lines.
We get it.
That's a lot of zeros. Okay, so I'm going to do it the easy way because I like numbers that end in 0. They're so easy. 4 times 7 is 28. And then I have 1 0 over here plus 102, 103, 104. So I have 4 zeros, so all I do is do 4 zeros. And then I have to add in my comma.
Holy smokes, that's fast.
So much faster.
That was like a 16th of the time it would have taken you to do it the long way.
I know, it just makes it easy. So don't be scared of these zeros because they'll just make it go faster.
Sounds good. All right. So what you've learned today is to remember to use your count how many zeros you have in your in your power of 10, and make sure that that same amount of zeros are in your product.
You also learned that Mrs. Roy and her husband are very compatible.
Check out that app. Ask me about the name of the app in class.